What's up guys, Onmaths here, and today we're looking at similarity and congruence. So first up, AQA question, and this is asking us to explain why these two triangles are congruent. Now what does congruent mean? It means they're exactly the same. Yes, they're different ways up, but apart from the rotation, and they can be flipped as well, but they are the same triangle. So if you cut it out on card, if you cut the left one out accurately with card, it would fit exactly into the right hand one. So it's given us four options. The first one is all the sides are the same. Okay, so it means that we've got all three sides on each of these. Well, we don't have all three sides on each of these, we only have one side, so no, not that one. The one that makes me feel that it's the answer is RHS, and the reason why is because the R stands for right angle, and these both have a right angle. They also both have a side, which is the S, but they don't both have a hypotenuse. And I think the trick in this question is that people would just circle RHS because they're right angle triangles, but they don't both have a hypotenuse. In fact, neither of them has the hypotenuse labelled, so we don't know that the hypotenuse is equal, so it's not that one. Next one is side angle side, but again we only have one of the sides, so no, not that one. The last one, hopefully it's this one, is angle side angle. Well, we have the angle, we have the adjoining side, and then we have the next angle, it just happens to be 90 degrees. But both of them have the 32 degrees, then the 7 centimeters, then the 90 degrees. So the answer is ASA. Next up is Edexcel question. This time we're working with similar triangles. So we're told that the two triangles in the diagram, which are ABE and ACD, are similar, which means one's an enlargement of the other. Now my heavy recommendation for these types of question is always draw out the triangles individually, and that generally helps. So I'm just going to quickly draw out both of these triangles, badly, but I'll try my best, and then label the sides we've got. So we've got 12 centimeters here, I'll leave out the centimeters, 8 centimeters there. Then this is going to be 8 plus x centimeters, and this is going to be 12 plus 3 centimeters. Well, we know 12 plus 3 centimeters, it's going to be 15 centimeters. Okay, so the first answer in this, and it says there's two possible values, which we'll come to later on, but the first answer is pretty easy, because we've just got to find out the scale factor between this one and this one. And so we do that by just doing 15 divided by 12. And we can divide top one by 3, so we get 5 over 4. And so we've got to do the same with this one. So we're going to times that by the scale factor, so times that by 5 over 4. And we'll do the working out down here, so it's 8 times 5 over 4. But what does that give us? That gives us the new length, which is 8 plus x. Okay, let's get my lines down. Let's solve this. So I'm going to first of all do the 8 times 5 over 4. So 8 times the top. So whenever you've got a big number times a fraction, you just times it by the top. So that becomes 40 over 4 equals 8 plus x. And 40 divided by 4 is just 10. Take away the 8 both sides. And we've got x equals 2, or 2 equals x. So we've got one answer nicely. Let's just extend my lines, make it a bit neater. Right. Now you might be really struggling to figure out how the heck we get the other answer. So it says it's got two answers. And this is the really funny thing, is we have assumed that this one here corresponds with this one here. Okay? But this one here could have corresponded with this one. Okay? So if I draw out the triangles again, so I'm going to do the first one exactly the same. I'm going to change that one. And we've got 12 at the bottom and 8 there. But if I do the one on the right, kind of flipped over, because it absolutely could be flipped over. And so we have 8 plus x down here and the 15 here, and this time those are the ones that correspond, then we will get a different answer. So we do the same again. So this time it's 15 over 8 to find the scale factor. And so we've got to times that 12 by 15 over 8. And so again, we're just going to do the same as we did before. So it's going to be 12 times 15 over 8 equals 8 plus x. Get my lines down. Okay, so we're going to do 12 times the 15, which will be about 100. It'll be 180. You can do some long multiplication to work it out. Again, this is not a calculator paper, so you'd have to do this without a calculator. Then we're going to divide by 8. Now, when you divide by 2, you halve it. When you divide by 4, you halve it, then halve it again. When you divide by 8, you halve it again, and then halve it again. Okay, so we're going to halve it and we'll get 90. We're going to halve it again and we'll get 45. Then halve it again and you'll get 22.5. And you could do this with long division like the bus stop method. That would give you the same answer. Plus x. Right, take away the 8 from both sides. We used up a bit too much room here, but we're going to do 22 take away 8. Or sorry, 22.5 take away the 8. And we get 14.5 equals x. So our two answers are x equals 2 and x equals 14.5. Last up is our OCR question, and this is about understanding similarity with volume and with just normal scale factor. Okay, so I always draw little diagrams with these, just I find it helps. So we've got two tins, and I'm really bad at drawing tins, clearly, and one's bigger than the other. If one's bigger, I always overreact, make it much bigger. Okay, so one of the tins is 40 meters squared, and the larger one is 60 meters squared. Now I've cut out question A because it's nothing to do with congruence or similarity. So if you want to have a look at question A, then go to 2018 June paper 6. And now paper 6 is a calculator paper, so we'll be relieved to know. And it says the radius of the standard tin, which is the smaller one, is 10 centimeters. And I think we're asked to find the radius of the bigger one. Simple as that. So we've been talking about scale factors, and this is exactly what we need to do with this. We need to find the scale factor between these two. So a scale factor is what you times the left one by to get to the right one. Simple as that. Now it says it's 50% more. So it says the volume of the large tin is 50% more than the volume of the standard tin. But that doesn't really help us. That's interesting to know, and we can sort of see that ourselves in the diagram. 50% more means that we times it by 1.5. 1 because we're keeping it the same, and then 0.5 because we're adding half to it, right? That means we're increasing it by 50%. So if you weren't given the values of 40 and 60, then the scale factor would be 1.5 just from the 50% more. Okay, so if you start off with 100%, you add 50%, you get 150%, and as a decimal, as a multiplier, that is 1.5, and that's your scale factor. So we didn't need to know the volumes of the two tins. We could have done it without. Okay, so now we think that we can just get that 1.5 and times it by 10 to get to the new radius, but no. And this is where the different things come in. So if you have linear scale factors, and we'll just call it SF, okay, then you times by just the linear scale factor. For areas, if you're going from the small to the big, and the linear scale factor is SF, then you'll times it by SF squared. And for volume, no surprises here, you times by the scale factor cubed. Okay. Now the problem is we're given the scale factor for the volume is 1.5, right? and we need to find out what the linear scale factor is. So to go from the linear scale factor to the volume scale factor, we cube it. So to go the other way around, if we've got the volume scale factor, which we do, it's 1.5, and we're looking for the linear scale factor, linear just means it's not a volume or an area, it's just a straight line, which a radius is, then we need to do the opposite of cubing, which is cube rooting. Okay, so to find the new scale factor, it's just going to be the cube root of 1.5. So we get our calculator and we type in 10 times the cube root, which on my calculator is shift and the square root, gives you the cube root, 1.5. And I'm just going to write that down for the examiner. So 10 times the cube root of 1.5. It's not a very straight line there. Let's try and sort that out, make it look a bit nicer. And it says 11.44714 blah blah blah. And so probably round it to 3 sniffing figures and always show what you've done. So 3SF, always show what you've rounded it to.